All right, so I've resumed recording again. Let's carry on from where we left off. Okay, so what am I sharing at the moment? Let me see. Okay, yeah. So typical questions for exam, the search procedure. I don't think I've even asked a question on it. Can you imagine that I have never asked a question on what you are seeing on the screen right now? Never. I've never asked a question. Okay, the search procedure should be such that you can even decide that I want to choose a route. You see what Google has been giving us, there's more to it. You can search the network in such a way that take me on a route in which I'm always facing north, so that the sun, I will not be facing the sun because I have an eye problem. Do you understand how these things work? Yeah, not that I have an eye problem. Maybe you have installed what? A solar system, and it's been oriented on the car that I'm traveling with. This car could be the car that's actually, if you like, applying a certain rule that you are working on. I mean, like, engineering is solving any problem like that. It's an engineering problem. We can actually search all links that propagate from a node, moving out one link at a time and gradually accumulating the cost of traveling. So what it actually means is that we can find a cumulative cost. That is also possible. We can seek to find a route that passes through the fewest number of nodes, even if it's not necessarily the route of lowest cost. What does that mean? How can we go on a network and then choose to go on nodes, the fewest number of nodes, to get to a destination? So getting to a destination may make use of so many nodes. What does it mean? These nodes are like places where you're going to have, junctions. For some reason, you want to avoid that. We can do that as part of our search procedure. So one of the commonest questions that you ask, I think I just talked about this, is what we call the shortest path. People just try to find out. Uber drivers are trying to find out the shortest route. These days, people, hey, guys, we need to get to Osu right now. We need to get to town right now for the meeting. Let's go. 4 people in the car. Someone will say, okay, you use the Google for us. I don't think it's surveyors and engineers who do this. Ordinary people do this. Okay, ordinary people. So if you're an engineer and you've been using this, Google Map shortest route, then when you are in a hurry, then it means you are really having a problem. If the Uber driver takes a person from one point to the other, okay, and as he's taking you, all right, you don't even check if the route he's using is the shortest route. He could just be making, a fool of you. It's all right, because he chooses to use whatever route he wants to. He sometimes they follow the map that Uber is actually, recommending, but it may not be the best route to use. All right. So when you are planning the fastest route from one city to the other, you may want to do this. Is all right? Okay. First, for an engineer, you'll be thinking, okay, I'm designing a road. I want to see the impact on the existing road network. So that's what you're looking at. I'm designing a road. What is the impact on the existing network? That's what you're looking at. Shortest path. Okay. Is that going to be the shortest path? That question is always going to be asked. Now, on top of this, you see the Dijkstra's algorithm. So Dijkstra comes up with this algorithm. And what is the algorithm? Algorithm is just a step-by-step, okay, instructions that are helping you to solve a problem. Are you okay? So if you break down a problem into steps, then you find a solution. So that's why I keep telling people that the question itself, the problem itself is a solution. Is that okay? You break down a problem and then you solve it algorithmically. In other words, you go through steps. Is that okay? So Dijkstra's algorithm, how does it work? Dijkstra's algorithm. So this was algorithm. If you look at the screen, you will see that I'm trying to move from point A and I want to get to point G. Is all right. Okay, but in between, I don't have a straight route. Naturally, straight routes just don't exist. I want to go to Kumasi. Oh, that's your straight route. Just go on it. The only thing I realized with going from Accra to Kumasi is that it's a straight route, really. And that's a problem, isn't it? So people are dying on it a lot. Okay. Sorry for that, but that is what is happening because it's just a one straight route, and that shouldn't be the case. So we should have alternatives. Is all right. So how do we evaluate? Okay, according to Distra, if I have such a network with weights, and the weights, another word for the weight to be the impedance, okay, or another word for it to be the cost. Right? Okay, the cost of traveling or traversing the network is given as a value, as a numerical value. So in this case, we are talking about 2, 3. All these could represent distance, could represent dollars, money. Are you okay? Could represent friction, something like that. Are you okay? Because depending on the friction, so if you take that weird example, so there we go. What is the shortest route between A and G? So naturally, I could just ask the class this question, and how would you, the way you solve it is the way Distra did. Are you okay? You will start by adding the values and be checking which one is the smallest, because it's a cost, and so that you want to keep cost minimal. Are you okay? So A to E to J is going to be 3 plus 3 plus 1, that is 7. So okay, so that may not be the shortest. Let's try A to B to J, that's 3 plus 2, that's 5. Okay, so 5 is so far the minimum. And A to through B through D to J, that's 8. That is also too much. You see that? And so this is the algorithm. Okay, so the algorithm can be repetitive, okay, process. So that we don't do it the way I just did it. This strategy didn't recommend it that way, that just sum all the way to the end and go and check, go and sum all of them again. No, what this strategy recommended was that you take from A to B, okay, and then compare it to from A to C. Then you see which one is the minimum. All right, the minimum is 2. So initially, the algorithm picks A to C to be the route. It selects that link. Are you okay? Then from C, we start moving again. Then the cumulative cost becomes 4 in this direction. Now 4 is greater than 3. So A through C to B is more expensive than A to B. So now even A to B is becoming an option. So we're not looking at that. Then we try A to C to D, that gives us 3, still better than A to B. Are you okay? So we now here at this point, we selected A to C. All right. And then we keep going, trying A to C to F. That's very expensive. Is all right. So which link do we select from here? It's going to be A to C to D. That's like naturally the link that you pick. So we have 3. Then from A to C, so we are D now. So D, let's add on 3 plus 3, that will give us 6. But then let's not forget that A to B, now we can also start comparing, the distances cumulated from A to B to the other points. Then you realize that we can't continue from A, C, D going to G, because A to B to G. So this is how, Distra designed his algorithm to move from node to node, accumulating costs. Are you okay? All right. So if I clear this, you can see that here we are considering the 2 links. Okay. All right. And then you can see the distance involved when we pick A, go through that, B, C, so C to A, whether we should accept it or not, we just saying no, and we still at A. So A is the beginning, is okay. And then we are just moving from node to node. When we go to the next one, you can see that at this point we're choosing. So we choose that the green one is a selected one. Then we keep on adding on. Are you okay? Checking it whether we should select it or we shouldn't. Okay. So this is actually a simulation. I'm not supposed to show it. It's a PowerPoint. We click it and then it just be changing colors. That's the idea. So let's take it as it is. I think it still gives you, you know, what I mean. I mean, it's clear, isn't it? All right. So there we go. We don't want to go in the brown ones, the brown links. We want to use the green one. Okay. So here the decision was between points, this point here. What was this point called? Don't keep it in my head. All right. I just want to get, so B and then C, you get it. Back to the original. All right. So distress algorithm works like that until we finally select the final one. A through B through J. Are you okay? Then we know that that's the one we should go for. I mean, it's an algorithm. Honestly, it's a program that is written, that is being used. So most of, I'm sure it might be improved with artificial intelligence by now. That is the way people are going. Okay. You're not finding shortest routes based on just calculating. Are you okay? All right. So we label them as we go, etc. Please, guys, that's the idea. All right, let's move on. But we can make use of what we call heuristics. Are you okay? Heuristics really allow you to just decide, remove, don't look at some links when you are trying to find the shortest route. There are some links that you shouldn't even consider. Are you getting that? Okay, so you're moving from Kumasi to Accra, you are heading down south. What are you going to do over there? So the algorithm should not consider that. So the heuristic allows us to solve problems, to reduce the search space as we have put in here, so that it reduces the load. Are you okay? If you're searching for something and the space within which you are searching is too huge, it takes more time and resource. So we can make use of what we call the imperfect solutions or heuristics. Are you okay? So for example, in the example given, a link might only be valid if it points towards the destination. You get it? The angle between the link and the line from the node to the destination is less than. See that things like that can be done. Like I said, just give me directions that point to my direction, my destination. Don't be going, because I keep on telling people that when you're moving from Kumasi to Accra, and then someone actually showed you the map of Ghana, at a point you realize that you are not really going south. Okay, you're actually going in a certain direction. And for all you know, that path was used by our grandfathers for a long time. And usually when you are constructing roads, it's good to use existing roads. Are you okay? There's no need to build, you know, a new road whilst you have an existing path. You build on the existing path. That is a recommendation. Are you with me? All right. So that is shortest route. The advantage of it is that during an emergency, we need that fire service. I don't know if they've been using it. Maybe they are. I don't know. But when your shortest route is being provided by a company in the US, you should be careful, isn't it? Do they even care about you? All right. Not to sound political. All right. Business journeys, taking a route, Charlie. I need to visit all my clients. Are you okay? So you need to plan your routes so that you just don't go in circles and waste time and money. Are you okay? All right. So there you go. This is what we see in Google Map most of the time, right? I'm trying to get to Malam Junction from Medina Market, okay? Which route should I use? Naturally, you start having funny thoughts. Are you okay? That you should be going through Circle or something like that. I don't even know if this Circle. Yeah, Circle will be around these places. Yes, but I think if this is Pinterest, then that's the high road. Are you okay? This is the motorway. I mean, I think I'm hungry. Not the highway. This is a motorway. Are you okay? All right.
Yeah.
So if you yes. Right. I thought someone called me. But so you have in your mind, you know, for a long time when I came to Accra, I was actually driving through Accra to get to, you know, Kaswa, and I did it for some time. And then someone was like, "No, you're going the wrong way." But in my mind, so we have what we call mental maps and all that. So that is why you need the algorithms. Are you okay? By God's grace, we have these tools. We should just use them. And then when I checked on the map, I was like, this person, these guys helped me because honestly speaking, how could I be going in the wrong direction? You know, so that is how it is. The shortest route works like that. Ask a question, draw, if you ask a question, draw the Poquat interchange or just draw any interchange. Okay, sketch it with lines. Just use lines only. Don't go drawing a section. Is that okay? Draw it in planimetry. In GIS, you don't do sections per se. You don't. Okay, everything we're talking about in GIS is about locations on the surface of the locations is in planimetry. So please draw nicely. Don't be drawing. We are not doing artwork in GIS. We are talking about lines, points, and polygons. You don't draw, polygons, and you don't close them. So if it's a polygon and it's closed. If it's a line and it's hanging. Okay. If you're supposed to represent the connections, know that the person, the lecturer, your professor is talking about connectivity in topology. There's nothing else in concept in GIS where someone will talk about connecting the roads, connecting. Once the word connection comes, you should just know where the answer is pointing towards. Is that okay? So the attributes, yes, directions, restrictions, impedances, yeah, all that should be factored into your network analysis. In fact, there is one solution called a traveling salesman's problem. What is a traveling salesman's problem? Okay. Traveling salesman problem is one of these. The traveling salesperson has to visit a number of customers, then return to base. Is that okay? And he or she needs to have the details of the shortest talk possible to the size to visit. In other words, we can look at how you visit several places and come back to this. In one particular exam, I asked a question about a facility, a COVID facility that's being set up, and doctors need to visit their patients. Is that okay? So the question was kind of like off a bit. Are you okay? So you are supposed to construct a facility like that. So all the questions was about the construction of the COVID facility. And locations, places. That's what GIS is about. Now, the question was that if the doctor needs to visit his clients, okay, if he's supposed to visit his clients, then how is he going to be able to do that effectively? So he does that by making use of the traveling salesman's problem. Is that okay? Where the distances to visit all these patients is minimized. Is that okay? All right. you minimize the distance it's traveled. So if you have to, on the network, you picture yourself on the network, you need to visit someone. In fact, I have done it before in the house. Sometimes I'm thinking about, okay, I need to go to bank. Where's my bank? East Legon. I have to go to the mall. What am I doing? I'm buying potatoes. I need to come to market, then buy fuel. I always buy at Goyle, and I realize I'm in the center. Are you with me? It gets to a point where you realize that you're stuck in terms of the way you think, solving problems. And so this is the traveling salesman's problem. If they don't work their routes or their routes very well, they will end up buying a new shoe every time. I'm talking about the man that goes from door to door selling clothes. Yes, you realize that they have to pick the shortest route. So that came in an exam. All right. There's also another network, problem. It's not a problem, but it's a solution. The isochrones. You can talk about isochrones. Isochrones are lines joining points of equal time. You can have a map that shows points where you can reach within 5 minutes, points where you can reach within 30 minutes on the network. So in other words, you can have this map and then shade a zone or have a zone, and the zone will now indicate that, okay, everyone within the light blue or whatever, turquoise blue color, these guys, it would take them 30 minutes, are you okay, to get to a particular facility. There you go. So you can make a decision based on that. You can just decide that they have to move away because there's a construction going on. There's a whole lot you can do. I can create scenarios that would demand that you think about isochrones, are you okay? Which are about places that you can reach within a certain time. It's